calculate the volume of a PVC pipe and the exit velocity of the water leaking out of said pipe, using previous knowledge and theorems like Torricelli's.
Do a comparison of the real position of falling water and a numerical simulation of the system.
We drilled a 4 mm hole in PVC pipe of a 5 cm diameter and added a cap so the water wouldn't leak. We filled the pipe up and we let the water come out of the drilled hole. We measured the distance the water reached every 3 seconds. We made sure to measure the radius of the pipe, the distance between the hole and the ground, and the length of the pipe, etc.
We then proceeded to calculate the volume of the pipe using the following formula: P times radius squared times the height. We subtracted the distance from the hole to the ground, from the top of the tube to the ground, to get the height above the hole. Then we calculated the velocity of the water leaking out.
We also calculated the area of the hole using pi times the radius squared. We found the missing volume and subtracted it from the original volume. We found the new height using the new volume.
We started off not knowing how much water we should put in the PVC pipe, and we didn't know how to measure the distance of the falling water correctly. In the second attempt, we filled the PVC pipe completely and figured out a practical method to measure the distance. We had one of our teammates get the data with the measuring tape, while another one recorded the results. We found that the pipe had a diameter of 5 centimeters. The distance between the hole and the ground was 88 centimeters. We placed the pipe on a table and drilled a hole of 4 millimeters of diameter. We calculated the height above the hole, which turned out to be 87 centimeters.
Torricelli's theorem makes a relationship between the speed of water, in this case flowing out of the hole, and the height above the hole where the water is coming out. According to the Physics Stack Exchange website, Torricelli's law says that the speed of the water leaking out is affected by the height of the fluid above it.
As the water comes out of the pipe, the height decreases, making the velocity of the exit of the liquid decrease as well. If you put a cup on the top of the pipe and apply pressure to it, the exit velocity will increase.
We calculated the initial velocity and the area of the hole. Then we calculated the missing volume in 1 second and subtracted it from the initial volume to find the new one. Using that newfound value, we calculated the new height.
We will recommend to do the experimental procedure on the ground because it is easier to calculate the distance the trickle of the water travels. Another recommendation for the experiment procedure would be to take the distance every 3 or 5 seconds, because if you take it every 1 second, you may lose the exact distance. For the calculus, we will recommend to do it in 1 second, because 3 seconds apart is too much and the graphic will be inconsistent.
In conclusion, we estimated the tube's height by using the formulas of area, volume, and initial velocity. Even when the results were not the expected, we learned not only the water height can be calculated, but also the distance the water has.